Welcome to the TPC Desktop video series. In this video, we'll look at creating a geodetic center of section for the Public Land Survey System. In this video, we're going to be using an example that we put together for some training we did for the Bureau of Land Management. So if we go to Videos Online in the Task Manager, Traverse PC will open up your browser and take you to the Videos Online page on our website. Click on the BLM link here, and you'll be able to download an outline, the maps, and the sample files we're using here. If I just scroll on down, there's about 34 lessons or so here, but we're going to do this one called Computing a Geodetic Center Section. And you can follow along in the outline as you watch this video, and then go back and run it yourself. Let's close that out. Let's open up this file. And let's go ahead and insert the west quarter corner in here. So I'm going to right-click the east quarter corner, tell Traverse PC I want to edit Traverse, and it opens me up at 600/440, the east quarter corner. I'm going to come down below that, press the insert, and I want this point to be a side shot. It's just an easy way to display it here on the drawing. So let's make that a side shot, and then let's recall the west quarter over there. So let's recall 500/440. So 500/440 and press enter. Traverse PC tells us that point already exists and brings it into the drawing. Now I just want us to see kind of what we're working with here. So let's do a zoom extents and redraw, and let's just change the color of that side shot by double clicking any part of it, and then in the side shot properties, let's just change that to something like a dark red or something we can see more easily. So now this kind of gives us an idea of what we're working on here. Here's our east-west line between the west quarter and the east quarter. Here's our north-south line between the north quarter and the south quarter. And we're going to take a look at computing the geodetic intersect in the middle of this section. So let's go ahead and zoom back in on the area that we're going to work with here. This will make the point label just a little larger, and we'll be able to see just a little more clearly what we're doing. Drag that over. I think we'll leave it right about there. Okay, let's go up to the intersect dialog up here. I'm going to click this and open it. And one of the new features of 2014 Release 1 is that the intersect dialog now can work in whatever distance and direction type either the survey is using or the Traverse is using. So instead of just seeing grid bearings and distances here, in this case now we're going to see true bearings and geodetic distances displayed in this dialog. So this is new in TPC Desktop 2014 Release 1. So let's start by recalling the north-south line on the left side of the dialog, and we're going to recall the east-west line on the right side of the dialog. And this is important because it's only the right side of the dialog that lets us say, I want to use a latitudinal arc. And remember, this computation of a center quarter for the Public Land Survey System isn't the intersection of two geodesic lines. It's the intersection of a north-south meridian line and a latitudinal arc passing through the east and west quarter corners. So it's a very specific computation, and Traverse PC does it just that way. So let's start here on the left side, recalling our north-south line. I'm going to click this little chevron next to the from point. Then I'm going to come up to my drawing, and I'm going to click 540/500. And Traverse PC is going to recall that as the beginning point of that north-south line. Then I'm going to click this chevron next to the bearing, and I'm just going to click anywhere on this north-south line. And Traverse PC is going to bring in the true bearing from 540/500 to 540/400. So I've now defined my north-south line. Let's do the same over here. I can just click the double chevron, which allows me to pick a line, and I'm going to pick the line from our east quarter corner to our west quarter corner. Now we inserted that so we could kind of see a picture of what we were doing, so we'd have that east-west line to look at. But how convenient is this then to just go ahead and select that line, and Traverse PC brings in the east quarter corner and the west quarter corner for me automatically. So we've provided all of the information that Traverse PC needs to compute this geodetic center section, and we've told it that we're going to compute the latitudinal arc. And I want you to notice that here in the computed intersections, one of the boxes went from gray to white. That tells us that this intersection has been computed and it's ready for a label. So let's come in and tell Traverse PC that we want to label this point 540, 440, and I'm going to put an uppercase G for geodetic there. So notice that we're using GCDB point labels, and I'm just taking the latitude to add something to the end that distinguishes that this is a geodetic intersection. Let's go ahead and save that. Now, I've got a couple of options here. One, I could certainly just plot that, and Traverse PC would draw it onto the drawing there. But I want to come up and actually insert it into the retrace survey, because a retrace survey goes from the north quarter to the south quarter, and I want it to go right through this geodetic center quarter that I computed. But before we do that, I want to show you how I check my intersect just to make sure everything kind of got computed the way I wanted it to. I come back to the intersection dialog with my 540, 440G entered, and I choose summary. Let's bring that up. Let's just take a real quick look at the summary information that Traverse PC gives us here. So Traverse PC puts a few spaces after the last summary that was created and gives us an intersection summary and tells us this is based on true bearing and geodetic distance. So I've got an additional line down here that says this is geodetic distance at project elevation of 3,800 feet per the PLSS, and I'm using true bearing based on mean course conversion per the PLSS. And then I want you to notice that there's a given section and a computed section. So this is everything I started with. I started with the north quarter, and I ran this bearing through it. And then I started with the east quarter and the west quarter. And Traverse PC, of course, gives me the latitude and longitude and convergence at each of those points, along with the coordinates. And then I basically am going to compute my intersection on the line from the east quarter to the west quarter, being a geodetic arc at this latitude. So Traverse PC is giving me some great information about what actually went into this computation. And then, of course, if I scroll down here to the computed, here's my 540, 440G, again, with the coordinates and the latitudinal arc. And this is what I like. Here's my information from the west quarter to my new center quarter. Here's the information from my east quarter to my new center quarter. So I've got kind of some summary information I can look at so I know the orientation of that new geodetic center to the east and west quarter corners. Let's close that out now, and let's come back up here to our retrace traverse, and I'm going to come down and highlight this south quarter down here, 540, 400. I'm going to press the insert key, and I'm going to recall our geodetic center quarter. So 540, 440, don't forget that uppercase G here. Traverse PC says that point already exists because I just created it in the intersect. I'm going to recall that point now, and here is my center quarter recalled into my retrace traverse. Now for comparison, let's come back and compute the grid center quarter, and let's plot it next to our geodetic center and show them graphically and then do an inverse between them. And let's see how different they are at this geodetic position, latitude and longitude. So I'm going to start by telling Traverse PC I just want to clear this dialog, and then I'm going to pull down the Show Options button, and let's go ahead and choose a grid distance and a grid bearing. And did you see that little warning about the latitudinal arc? Traverse PC said if you're going to choose a grid distance, I can't do that latitudinal arc. That only works with the geodetic distance type and true bearings. So just kind of looking out for me there. And let's just repeat the process we repeated earlier. So I'm going to choose to start from my north quarter. This time, however, though, I can't just pick this line to the geodetic center of the section. I need to go 540, 500 all the way to 540, 400. So we're going to use an equation for that. And I'm going to say 540, 500. The dot dot is the equation that says from this point to the next point, which is 540, 400. Enter. And Traverse BC just recalled the grid bearing between the north quarter and the south quarter. Now we're going to basically do the same thing for the east-west line here. So we're going to start at our east quarter corner. We're going to click that 600, 440. And Traverse BC recalls that into the dialog. And again, for our east-west bearing, we're going to say 600, 440. And the dot dot tells us again that we're using an equation. And now we're going to go to 500, 440. Press enter, and Traverse BC brings in that east-west line for us. Now, just like it did for the geodetic intersect, we see that there now is one of the computed intersection boxes that changed from gray to white. That tells us that we have an intersection computed. So let's go ahead and put in our GCDB point label. Let's put in 540, 440. And let's go ahead and tell that this is a grid point. Remember that last time we used a G for geodetic. So I'm going to put a letter P in there, uppercase, indicating that it's a planar point, not a geodetic point. Let's go ahead and save that. And then a real easy way to show this is just to plot it. The Traverse BC keeps a separate traverse called point plots. And I can go to any COGO dialog and say I want to plot that computation. And you'll see that it added it to the drawing. Now things are kind of tight in there, so I'm going to use a tool called Window Extents. It's available just as a command from the View menu. And what that does, it says I'm establishing the new extents of this drawing. And that allows me to create some new scaling in this. Now I'm going to go ahead and zoom in. And let's go ahead and do that Window Extents one more time. We're going to need a pretty tight window here to do what we want. Okay, I think we've probably got enough here to show for that. Notice that here's my 540, 440G, my geodetic center of quarter. Here's my 540, 440P, my planar center of quarter. Of course, right on that straight line, okay, between the east and west quarter. This is not a latitudinal arc we're plotting here. It's just a straight bearing line, which is where this planar intersect ends up. So I can see that I've got two separate positions for my planar quarter versus my geodetic quarter. And that's exactly what I want. Of course, now it's very easy for us to come in and say, I want to do a random inverse between these two. So I'm going to come up to my COGO toolbar, choose random inverse, and let's go ahead and bring this right down and choose 540, 440P and 540, 440G. And I can see that I've got basically 1600ths between those. And I know that based on this position in this state plane grid that I'm working in, that that's a reasonable offset for that geodetic center quarter. So I'm feeling pretty comfortable now that Traverse BC certainly can compute a planar or a grid center quarter, but can also just as easily compute that geodetic center quarter for me per the PLSS.